Welcome everyone to the Construct Innovate webinar series on sustainability planning and construction. So this is our third week of the webinar series, and this week we're concentrating on passive house design. My name is Jamie Goggins, and I'm the Director of Construct Innovate, which is Ireland's National Research Centre for Construction Technology Innovation. And we're running this webinar series in association with Engineers Ireland. So absolutely delighted today to have a stellar lineup of speakers. Lots and lots of experience here today on the webinar. So we have Jeff Colley, who's the founder and editor of Passive House Plus, who is going to talk to us about Passive House and why we should build passive. We've got Olga Marquez, who's from Helena McCallum Architects, and she's got a lot of experience in delivering passive houses and is going to give us some of the lessons learned from that. We have Hugh Weskery, who's managing director of Partel, and he's going to talk to us about the importance of membranes and ventilation. So in their company, they actually develop their own membranes and ventilation and do a lot of training and installation, are providing the product and installation and so on. And then we have Stephen Barrett, who's the carbon lead at the Irish Green Building Council, and he's going to look at the whole life cycle carbon analysis of the building design. So why do we need to be concerned about the greenhouse gas emissions associated with the products that we actually put into the buildings and that. So without further ado, I'm going to pass over to our first speaker. So our first speaker is Jeff Colley. So over to you, Jeff.
So yeah, look, thank you for the opportunity to speak here. Grateful to Construct Innovate and to Engineers Ireland for the chance. I wanted to speak specifically. I've been asked to speak on what passive house is and why it matters. I'll just crack into that. So, what is passive house to begin with? Well, it's an energy standard which is focused on solving the need for heating in terms of an active heating system in our climate zone, and in the cooling climate, it's focused on trying to solve the need for active cooling too. In many cases, you find it's a question of just minimizing the need. And of course, looking at what's happened to our weather in Ireland this year, we're facing different kind of conditions for our buildings too. So we may, without care, end up with cooling requirements on our buildings. It was created by a physicist called Wolfgang Feist and an engineer called Bo Adamson, unencumbered by earthly concerns such as building regulations, or such as the approach to building regs. I presume many of the attendees today have been privy to the process of changing building regs, as I have many times over the years. And building regs are not just about building science. It's a political process as much as anything else. You have a stakeholder engagement process to consider as part of that. And it's a question of trying to bring in the regs that the industry will be willing to accept as well up to a point. And that is not really an ideal starting point because, building physics don't recognize politics, unfortunately. You can build it out of anything. I know for many people, passive house in the past conjured up images of like a prefabricated house arriving off a truck from Bavaria, and that can be how you build it, but you could build it out of bloody animal filth if you want. So for instance, two extremes just picked as an example. This is a modular straw bale passive house in Hereford, which is performing beautifully. And this is the dreaded 9-inch hollow block. It's a single leaf hollow block wall wrapped in mineral wool external insulation, this as it stands is Ireland's largest passive house scheme, Silken Park in City West, which is soon to be dwarfed. It's not just for new builds as a standard. This is an extraordinary project. There is a version of in the passive house suite of standards. There's a standard called Enerfit, and this one it's a couple of townhouses in a posh part of Manchester, listed building, retrofitted to Enerfit Plus, which is Enerfit with a bunch of renewables and a big target in that regard, and petrochemical free. I mean, it's a kind of one of the maddest projects and most ambitious projects we've ever published. They even built, you see on the right there, bespoke triple glazed, stained glass windows. So they really kind of went above and beyond just to kind of prove that it could be done. It's not just for houses. This is the world's first passive house hospital, which was recently handed over in Frankfurt, much quicker than our own National Children's Hospital. This is one in the long line of schools in the UK. We have a couple in Ireland as well, but this is by Archetype, prominent English passive house architectural practice. Another archetype project, an archive building for Imperial War Museums. And this is a kind of remarkable one because normally people build passive house because you're trying to kind of create a comfortable, healthy environment for occupants of buildings while minimizing energy use and carbon emissions. In this case, passive house was chosen specifically because they had priceless artifacts, papers and artifacts from 2 world wars, and they had very strict requirements to keep them in very tightly regulated ranges in terms of temperature and humidity. And passive house without any windows was a nice way of being able to do that. It's pretty old as standards go. So back when we were all having our heads filled with Kevin Sheedy and Paki Bonner's save in Italia 90. And when Germany, most of Germany was celebrating winning a World Cup, there was one German who obviously his mind was elsewhere, and that's Wolfgang Feist. So he at that stage was the first passive house in Darmstadt in Germany was on the drawing boards. It was finished a year later. This is it here, photographed a few years ago. It's a 4-unit terrace, and that was, I suppose, the kind of proof of concept for the standard. It has 5 kind of key components in essence, and this is about essentially stopping the indoor and outdoor environments from kind of trying to equalize in terms of temperature and, dare I say, air quality if you've got poor air quality outside. And those ingredients, kind of key ingredients include high levels of thermal insulation, triple glazed windows with kind of insulated frames as well, and well sealed frames, and attention to the elimination of thermal bridging generally. So this is to spot cold spots within the structure that can enable vapor to kind of condense in the wrong spot. By the same token, air tightness. Interestingly, the founder, Wolfgang Feist of the standard, maintains that the reason they set a very onerous air tightness target, it's 0.6 air changes per hour, which for reference is probably about 4 or 5 times tighter than the average new house in Ireland now, and about 20 odd times tighter than the average house built during the Celtic Tiger years. And that's not just for energy. The principal reason the air tightness target was set at such an ambitious level was for structure, because Feist had noticed from studying early attempts at super insulated buildings from after the Iran and OPEC oil crisis, and there were a bunch all around the world, including in Ireland, that if you end up letting if you insulate but you don't air tighten, you end up letting vapor, moisture laden air condense in the wrong places of the building and potentially cause structural damage. And then the final ingredient in terms of components is, and I love this German, this is translated from the Institute, German into English, adequate ventilation strategy. And there is actually a grain of truth in that, because, ventilation is one of these areas where you can have too much of a good thing. You need a sufficient air change rate to ensure comfort and health. But if you give too high an air change rate, there is a risk that people will sabotage the ventilation system too. So adequate is not, it's a revealing word in a way. There's a 6th magic ingredient too, which is quality assurance. We feature in the magazine lots of projects, including non-passive houses, and it's remarkable. I mean, the difference in the quality of the information we get from passive and non-passive projects. I mean, it's improving a little bit with the non-passive projects these days, but what you'll tend to find is that you get far much more information. I can think of, we get folders of hundreds of photographs showing, measuring tapes showing the insulation thickness, showing all of the kind of key details. Because evidencing, and in terms of a certified passive house, the evidence to show that the works were done properly is kind of critical. So why does it matter? Well, according to UNEP, building energy use is equivalent to, or is responsible for about 27% of global CO2 emissions. This is a kind of a key issue given that the world is on fire, and we need to act. It seems to work. Passive house seems to work. I haven't, in the time allotted, gone into the performance gap issue that we run into with many, historically that we've run into with low energy buildings, but it's a significant issue which passive house doesn't suffer from. So by way of example, here's a lovely 1990s graph from the first passive house. The target for space heating demand is 15 kilowatt hours per square meter per annum. In this case, you'll see the red bar is the space heating, the actual measured space heating. They were over 20 in the first year, and you'd expect higher in the first year, given that the building is drying out and people are familiarizing themselves with how to operate the systems. But since then, it's been in and around 10, give or take. So it's been performing better than the requirement in the standard. A UK study from a few years ago now of 97 passive houses showed that while the target was 15, in this case, the houses have been calculated to achieve 11.7. So a lot of designers will aim with a little bit below the maximum requirement. And the mean measured space heating in year one was less than 11. So that's, again, I guess, very reassuring. Rather than just, statistics, I think real stories really make a difference. This project is the first social housing project and the first passive house project to win the Sterling Prize, which is hopefully a sign of architecture kind of growing up and not kind of looking to garland monuments to the architect, but to actually look at providing high density, sustainable housing for vulnerable people. In this particular case, the Guardian ran an article on it, and the comments were just extraordinary. I mean, people talking about that it was life-changing, being able to save and pay back debts and pay vet bills that they wouldn't have been able to cover otherwise, reducing medications, getting away from damp issues. This tenant saying it was depressing to be told by the landlord that it was our fault with damp previously. Here we can dry clothes indoors in a day with no heating on. And then one tenant saying, the filter system is amazing. We try not to smoke inside because the air is so nice that we don't want to spoil it. This is an extraordinary one. Again, an 18-unit sheltered housing scheme in Exeter, designed by a German passive house architect who's very kind of dogmatic, I suppose, stereotypically dogmatic about the approach. Even though it was sheltered housing, very vulnerable occupants who need higher temperatures and who were there kind of, more or less all the time, he chose not to put heating systems in. Most passive house designers would put a small heating system in, but he didn't. All he put in was a little battery heater on the ventilation system to boost the temperature as required. 5 years after the project was completed, in 9 of the 18 units, the tenants reported that they hadn't turned the post heaters on at all since moving in. This one in Wales, a couple of years after moving in, the boiler broke down, and when the plumber came around to fix it before Christmas, the tenant sent him packing, saying they didn't want the hassle of having a tradesperson in over Christmas, to come back after Christmas. This one in Blackrock was interesting because there's an online dashboard for the ventilation system. A lot of passive house early adopters have been quite obsessive about the data coming out of the homes. And in this case, Stephen Tierney, the architect and client, logged into his dashboard when he was on holiday in Spain. And he saw the CO2 levels, the black line here, spike at about 7 o'clock in the evening and come back down again. You'll see next morning, right? They only got around to kind of acceptable levels at 3 or 4 in the morning. His teenage son was looking after the house and he caught him red-handed having a party. So it's kind of George Orwell will be spinning in his grave, but this is what that kind of data can tell you. It can be capital cost neutral, as bizarre as that might seem for people to comprehend. This project was done about 6-7 years ago. Madeira Oaks and then the Scorthy by Michael Bennett, seasoned enough passive house builder. He was able to compare against previous phases of the scheme that were built just to building regs. And in this case, he sold the first 4 houses, you won't believe this, to a builder's finish, 102 square meter, 3-bed semi-Ds, for €170,000 each. And there was an independent study comparing the cost with an independent QS, University of Ulster study led by Shane Coakley. The cost uplift per unit over the 2011 regs was quantified at €131. Which is scarcely believable, but that's with a good builder and a bit of cuteness. This is where you can get to. In that particular project, it was timber frame with cellulose as well, so a low embodied carbon build. Even the party wall there was cellulose and with an airtight board made by Meta Smart Ply. We have to test the noise transmission levels across party walls under Part D of the building regulations, and the acoustic consultant Ted Dalton told me, I've never seen a result like this. The results they got, 69 decibels, akin to the kind of sound insulation we attempt to design into walls between commercial cinemas. Extraordinary stuff. It's low risk and it's built to last. So this is 25 years after the first passive house was finished. A destructive study was done to check what the performance was like. The external insulation was cut off the walls, bone dry behind it. The windows, the U values are measured again, and they would have been bespoke rather than kind of mass produced. With all of the kind of the quality control that would have gone into that. All bar one were perfect. I think they reckoned the one that one pane where one section of window where the U value wasn't right, they weren't sure that whether it had lost its gas in the manufacture or over time. And the ductwork was checked as well. They'd never been cleaned and clean as whistle. Basically all of the components, including the MVHR system, again, which would have been a pretty primitive system, the ventilation system, bar the electronics, the academic study predicted that all of these things would last at least another 25 years. It's simple. So I just to conclude now, because I know I'm running over time. I mean, what we're talking about is, in some ways going backwards. In the 19th century, we had very simple houses where we had no central heating, you had an open fire and a jumper on the occupants to keep them warm. Then in the 20th century, we started getting very complicated with the advent of central heating, and some of the responses, frankly, to trying to go sustainable have added to that kind of complexity. There's a kind of a W. Heath Robinson element, if anybody knows the kind of Victorian cartoonist. And now we're in the 21st century. It's about going back to simplicity. Now, I would say in conclusion, any engineers among you, service engineers, for instance, in particular, I wouldn't be worried. You're not turkeys voting for Christmas in going for passive house. There's still design work required to prove concept, and you still have mechanical ventilation systems in these homes. You still need hot water, and it's a rare client who's brave enough not to put a heating system in. But what you can say with these buildings, we have enough information to know you can have confidence that when you hand over a building like this, that it's going to perform boringly well for decades. And I think that it's an extraordinary thing to be able to say. So thank you very much. I'd just like to conclude by saying, hawking myself for a minute. For the magazine, you can subscribe for just 40 quid for the year or request a free copy at passivehouseplus.ie. Also, I haven't included it here, but I have a podcast called Zero Ambitions, which hopefully people tend to find it's engaging enough, and it's available wherever you get your podcast. That's called Zero Ambitions. Thanks very much.
Brilliant. Thanks, Jeff. And both the magazine and the podcast, highly recommended. Excellent, really high quality, very informative all the time. Okay, so we move on to our next speaker. So Olga is next. So going to give us some lessons learned from passive house design. So Olga, would you like to be able to share your screen, hopefully?
So thank you, Jamie, for inviting us to be here today. My name is Olga, and I'm a project architect at Helena Macmill Architects. And today we'll be talking about our experience in delivering passive houses in the west of Ireland. So We are based in Galway. We have projects throughout the west of Ireland in a mix of residential, commercial, and public realm. And we have 3 in-house certified passive house designers, myself included. And all our residential projects are currently being designed to the passive house standard. Why? And I think Jeff has gone through quite a few of the whys already, but this is our whys. It is a way that we are sure to deliver comfortable, healthy houses to our clients that are extremely energy efficient and that achieve the environmental responsibility we set out as a goal for our practice. And in doing so, we're also future-proofing our buildings. We are also very keen that it is a validated and benchmarked high construction standard. And as Jeff mentioned, it's all about quality assurance from very early on stages through tender, through construction to completion, and in our case as well, post-occupancy evaluation. We are also very keen that it does require strict standards, both in the design phase and then in the construction stage. And then it usually involves the inclusion of high performance systems and materials, and it goes through a very rigorous process of testing and certification at the end. How exactly do we do this? How does it differ from a more standard architectural project? Well, there's a lot of investment needed in training. So all of our team members, all of my colleagues here have been trained in the passive house principles so that they can be applied very early on in the early design stages, which just makes it easy to comply with the standard later on. And then in terms of tools, we like to use the Design PH, which is a plugin you can install into our 3D software SketchUp. So it was very easy to incorporate into our workflow. And from there, we export into the more formal passive house planning package, which is Excel based. And that's where we like to fine tune details, things like final window sizes and actual materials that went into the build. And then depending on the construction type, we would have to go into our thermal bridge software, which we have actually started doing in-house as well. It just allows us to run quite a few more scenarios than we would if it was done externally. Yeah, so we've just gone through the tools that we use. And then next slide. So it's the 3 residential projects, and we thought it would be interesting in doing this, also showing 3 ways to 3 building forms that we've used. So next slide, thank you. So the first project is a 4-bedroom house, about 200 square meters of treated floor area. And you can see there we're meeting the passive house standard and heating load and heating demand. And the family has actually moved in. It's a lovely family of 6. They moved in December, and they've sent us their first ESB bills. So then they're very, very close to what was estimated in the passive house planning package, which we think it's very reassuring. And it's also in fact, meeting the Royal Institute of Architects 2030 Climate Challenge target for operational energy. Next slide, maybe, Sinead, thank you. So this house uses a traditional masonry cavity wall construction. So 2 blockwork leaves, one inner, one outer, forming a cavity, which we filled with pump insulation. The only difference here, it's a slightly wider cavity than the more conventional build at 200 millimeters. Now, the system is easy enough to describe, and it does seem to be easy enough to construct. Maybe next slide, Sinead. But once you get to details, it doesn't really lend itself to the more thermal breach free or the airtightness that is the requirement for the passive house. And you do have to go into a bit more complex detailing than your more conventional detailing. And in this case, for example, it's just the windowsill. And we've gone through quite a few different scenarios just to see how we could mitigate effects of creating a thermal bridge there and still comply with the passive house standard. So we ended up using a few different types of insulation in that one small area there, and also proprietary wall ties with low conductivity. Next slide. Thank you. And this is while we're delivering on passive house, we're also still delivering on architectural detail, of course, and it is entirely possible. It just takes a little bit more care in how you think about sequencing the works and just making sure that everyone on site is well aware of that precious continuity of the air tightness layer and insulation. So here we had an exposed ceiling, and you still have to think of how do you connect back to their more standard ceilings and leaving bits of membrane and tape so that they can all connect back eventually. Next slide, thank you. Here we're seeing a corner window detail. And we've gone through great lengths with our structural engineer to find a way to support the outer leaf while not creating a huge thermal breach with like a crazy steel plate bridging the cavity, for example. So we're using steel angles that are thermally broken and just slightly customized to allow a little bit of an overlap between the insulation and the window frame as well. Next slide, thank you. Here we're seeing just a fraction of the about 1 million heat recover ventilation ducts that go into a passive house, as I'm sure Hugh will tell you all about. We usually work with the suppliers to ensure the smallest, the lowest flow possible, so there's no noise in the rooms. So that just adds more and more ducts. It's one of the first things that we actually set out to discuss with the structural engineer, because quite a few of those actually end up needing structural openings through the product work. Next, thank you. One of the other steps we take in designing a passive house is to ensure comfort throughout the year. So that's also in summer. And indeed, it wouldn't be certifiable if it was expected to be overheating by a great amount. So the strategies that we like to incorporate go with natural ventilation for summer. And in this case, we had quite a few opportunities to have high level windows that just help create a great airflow in case it's needed. And we've also used mostly sliding doors for the internal doors of the living spaces, which just ensured those could be left open and there's a really good airflow going through the house. We also, in most projects, we like to incorporate blind niches so they do get installed by the users, and because they're just a good shading strategy. And in some projects where we have very large glazing areas, we go back to the numbers and see how are they actually balancing the views with the overheating, and if needed we can resize them or go back to the window suppliers and just try and come up with the low gains glazing specification. Next slide, thank you. So our next project is the smallest of them all. It's a 3-bedroom house, about 170 square meters, and it's been occupied for a while. We did receive some bills as well from our clients. It was from that period that we were all still locked up inside. So it might have been getting a bit more intense use, and it might explain that difference there from the estimation to the actual use. We should be getting new bills actually to see if that kind of came down or if it's there's something there that needs to be thought through. Next slide, please. So for this case, we've used a slightly more simple build. It's one single blockwork leaf laid on flat and wrapped externally with insulation. This does make for a lot more simple detailing of thermal breaches. And next slide, thank you. Just easier quality control on site, because you would actually see any gaps in your insulation layer. Next slide. You still have to take great care, of course, with all the junctions and places like windows that you still have to tape, but it is easily manageable, usually with the builder that's experienced on site. Thank you. And next slide. Architectural detailing was also a bit easier to manage, as you're not trying to hold that external blockwork leaf. So things like recessed panels and corner windows were just slightly more simple in terms of detailing. Next slide. So our last house is the largest of all of the projects today. It's on a spectacular site here on the Galway Bay, and that's why you're actually looking at a huge amount of glazing south facing, which of course goes with the client's wishes of being able to take in all of those lovely views that they have over the bay. Now this is already a bit of a reduced version of that glazing, and on top of that we've looked at creating a lot of overhangs where possible, and on top of that we've also gone back to the suppliers and specified a low G glazing, and we have achieved comfort throughout the year. Next slide, thank you. And the clients initially came to us also with the brief asking us to look at reduced embodied carbon energy, which we were delighted to hear because that's where we're trying to head as a practice. And so we specified a timber frame with as much natural insulation as possible. So this is what we came up with. It's there's plasterboard, the surface cavity protecting the very precious airtightness membrane. And then there's the timber stud work filled with cellulose insulation, the OSB, and externally placed wood fiber board, breather membrane protecting all of that, and vented cavity, and then in some areas cement board, and in some areas block work. Now, this system is pretty much thermal bridge free in practice. There's one tricky junction usually, which is where it meets the foundations, which can become a slight thermal bridge. Next slide, thank you. Which is why we went and looked at an insulated foundation for this specific project. Now, rafts are the most common form of foundation that we've been using here in the West, and this is a raft as well. It's just insulated externally, and it does tend to use a bit less concrete than just standard, more conventional raft. And on top of that, our structural engineer has helped us specifying a 50% GGBS use, reducing a bit the impact on the embodied energy and carbon of this specific project. Next slide, thank you. So a few final thoughts. Designing passive houses has allowed us to be designing and constructing for performance. And our ongoing post-occupancy evaluation is actually demonstrating how close we are to what was estimated, which is very reassuring. And many passive buildings from ourselves and our colleagues are being shown to be very close or meeting already the Royal Institute of Architects 2030 Climate Challenge for operational energy. So it's great. It's also a great system to demonstrate that we are meeting, because you can actually input the exact appliances that the clients have chosen to install in the house, because operational energy actually accounts for everything, not just heating. So it's your actual kilowatts on your ESB bill. Now, which form of construction? And Jeff had already mentioned, passive house is material agnostic, one could say. You could build it out of anything, and we've shown we have delivered out of anything. It's just how complex it is for us architects and for the builders on site to actually achieve the standard. Traditionally, masonry cavity does lend itself to a bit more complex level of detailing, and more issues to be solved on site just with sequencing of works. External wall insulation does become easier to deliver, but it's still very high in embodied energy. And then timber frame construction, it is a thermal bridge free design mostly, and the air tightness is easier to manage and can be easily accessible again if remedial works are needed, and it generally has lower embodied carbon, as I'm sure Stephen will review in his presentation. So next slide, that was it for me. Thank you very much, and there are a few links there if you want to find out more about it. Thank you.
Brilliant, thanks a lot, Olga. Okay, so without further ado, we'll hand over to Hugh Worski from Part L, who will talk about the membranes and ventilation. Over to you, Hugh.
Okay, hope everyone can hear and see the screen okay. Thanks, Olga and Jeff. Some really interesting presentations and points made. So today I'm going to try to talk a little bit about why we use membranes, not just what we have to achieve with passive house, but what else they do, and a short overview on ventilation as well. There is a little bit more to it. So lowering energy costs is the one we kind of clearly associate air tightness installation with, but for me there's a lot more to it. And We find sometimes with people, and I guess Olga has seen this as well, and different types or sizes of projects, it could also be to improve comfort levels. There's related benefits within that. So that could be two houses, built in the same location with the same form, one built to the Passive House standard and one not. And you'll find that the interior temperatures for the house that has good detailing and airtightness will need to be heated to a lower maximum temperature. So it means we'll feel comfortable at a lower temperature. Then when we look at air quality, generally that's an area that's really broadening in terms of people's access to controls or monitors. So we're starting to understand what's going on with their houses, and that's an understanding of PM 2.5, or could be the mold spores, relative humidity, VOCs, all that kind of thing. So an airtightness membrane is absolutely critical in preventing off-gassing of certain construction materials into the building. And the last one, I'm a member of Engineers Ireland myself, and I suppose I focus a lot on the structural integrity and what that means. I'm going to talk a little bit more about why and how we need to watch the layering and construction to have solid build-ups. Another key reason that we introduce air tightness layers is because we have to. It's mandatory as part of our Part L, Part F building regulations. So we need to be below 5. Which is interesting, as Jeff has kind of mentioned at different times. Our average air tightness in Ireland, I think it's about 2.2 right now. So we're exceeding regulations, and it's because we're introducing airtight membranes and systems that are proven to work. We do need to be aware that a ventilation system needs to be mechanical. If we're below 3 air changes per hour, this works, perfectly in Passive House. And the next one in Part F, where all ventilation systems must be validated by an independent, competent person certified by NSAI. That's proving to be a real change in the industry. So essentially, we have a blower door test, we have a BER, and now we also have this ventilation validation system. It's really shining a light on issues with installation. So can each room hit the required flow rates? And it's making people revisit ventilation. And now, in order to comply, it needs to be correctly designed. So right from the start, we need to have an appropriate design. Olga touched on that, where you do this early in the project. That's really important and gives you a much better chance to get a good quality design and a subsequent install. So it can't be a secondary decision, where does the system go? Let's put it in the attic. That's not a good idea. So early design helps a lot. I want to just talk a little bit before I start to talk about the structural integrity of buildings, why we need to consider our air tightness membranes and their other benefits. So the word breathability, most misunderstood word in construction, it refers to water vapor, not to air. So airtight membranes are more commonly known as an air and vapor control layer. So they're really critical about managing that moisture ingress into the building fabric. And Jeff, you had mentioned that a little at the start, but really we need to be careful. So we can have breathable construction, we can have non-breathable construction, airtightness systems, can be either one and work well in a passive house. The ventilation system is needed in each house. So breathable construction isn't a compensation for fresh air. It's independent. It's just water vapor. There is different ways to look at how each of these systems are measured. So if we take a breathable membrane on the outside, that could be an SD value of 0.1 to 0.5. So it's a measurable figure, something we can check. And air tightness membranes then can be a vapor check, a vapor barrier, or vapor tight. So looking at how we assess how air tightness membranes might fit into a typical construction. This shows a timber frame construction using, in this case, OSB on the inside and the outside, with a brick exterior of that and wood fiber insulation in between. So we know from our experience that this type of construction isn't optimum because the OSB layer here and here have the same breathability, the same SD value. Ideally, we want the construction to become more breathable as it goes to the exterior. So this is what our WUFI model looks like. We build all layers out. We introduce the ventilation shown in the cavity. And we get these types of outputs where we can assess the water content over a period of time. So the first one is what the OSB is doing on the outside layer in summer and winter. That's why you see increases and decreases. So it becomes quite dry in the summer and much higher, almost 17% moisture content. And the reason to show this slide is this shines a light on the moisture content being a little high, higher than we should need it to be. If we change that outside layer to a medite vent board, it drops the moisture content much lower. So increases the degree of safety dramatically in the building. When we look more at membranes and start to learn about their breathability, it brings us into the section or the area where we've got variable technology. So this is smart membranes that can give us additional drying functions in our construction. So essentially they're a range of products that can become quite vapor tight in winter and vapor open in summer. So it gives us an increased possibility for drying. These products are necessary in flat roofs. You do need to do a WUFI design on that to establish the safety, but broadly speaking, they're a good idea to help the building dry a little more. They typically come as a full system, so that could be the airtight membrane to fluid applied to tapes. So it's a full system, and it's a good idea to say, look, you know, I want to take a safe approach, and I'm going to look at specifying the virus system for all of my interior airtightness. Then on the exterior, I want to touch a little on the types of products we use on the outside. We at Partel are focused on monolithic membranes. That's a next generation type of exterior membrane. There is still a breathable membrane that is more commonly used called microporous technology. Microporous products have actual physical holes that facilitate the breathability of those membranes. That does bring with it some manufacturing aspects that mean these products don't last as long. So really when we look at an exterior monolithic membrane, they're things that can last 15 to 30 times longer than the other products. So there is an acceptance that a breathable membrane is a breathable membrane, that they don't change, but a short amount of time or consideration on specification can actually dramatically increase the lifespan of your passive house building or any construction. It can also help with the airtightness. Testing is a really important area for us. Thankfully, we're happy to say we're going to be working with Jamie and his team on this side of things as well. But it's something we're experienced with and we do a lot with. The type of test you see here is a shear test of a membrane or peeling test or of a tape. So you can see in this instance that the tape facilitates a lot of movement in the building. The adhesive itself is also able to do that. On the testing of systems overall, we're one of the most tested passive house institute overall system tests. We have 3 out of the top 5 best performing results, which we're really proud of. But we do like the system test because it's covering the airtight membrane, the tape, the adhesive. Short look at the structural thermal bridging. Olga has mentioned these products. They're something we do a lot of in Partel. They're recycled products. So actually from plastic bottles, we are producing Almavert structural insulated panels. So they can take the weight of windows and doors and can be a really good way to separate in a number of different types of construction. I'm conscious that we're running a little overtime as a group, so I'll keep this a little bit shorter. But on ventilation, it's a slide I'll often use, and I like it because what we want to do is get people to start thinking about ventilation as one of the first principles of design. So as humans, we've got 5 basic needs. That's the air, food, water, shelter, and sleep. So it's an absolute core, a necessary product for us to consider first and foremost, and it has enormous benefits to our health. We need our ventilation systems to remove CO2, supply the oxygen that we breathe, reduce the harmful VOCs, PM10, 2.5. They're a contributor to how we save energy, they help with dust and pollen, and also to control water vapor. They all do this, whichever type of system it is, by mixing. So we're mixing fresh air, filtering it, and mixing it with the air internally. The rate of mixing is what determines our air quality. One of the main reasons we want to work in this relative humidity optimum zone is because it makes things like bacteria, virus, fungi, or asthma, creating things really suffer. So they struggle in that area. So your ventilation system is critical, not just for the passive house, but energy saving aspect, but also for your health. There is really clear, thankfully in Ireland, we've got excellent design standards. So it's, if you like, easy enough to work out what we should be. And it's easy for us to check at the completion of a project, is it compliant? There's a couple of different routes towards compliance for ventilation. That could be a decentralized ventilation system using the E260 from Lunas. That is a fan that's in external walls. It works on a push-pull basis. So while one fan is supplying air, its partner is taking stale air out. And it does this on a continuous recycling base or recirculation basis. So each fan is doing 70 seconds in each direction. It basically does everything that a centralized system does, albeit in a different way. There is an eGo, which is a bathroom fan. It does supply and extract to wet rooms. On centralized systems, this is a nice example of what a centralized system could and should look like. Not up in the attic. That's where we see them all the time and people want to put them. They are much more efficient inside the heated space. They're easier to access, easier to maintain. So really we need to, at design stage, acknowledge that it needs some space and think about the overall design. Yeah, I've probably rushed a little, but I know we're short on time. So yeah, I think that's me for now. I'll take questions at the end.
Brilliant. Thanks a million, Hugh.
Cheers.
Okay, so move over to our fourth speaker. So fourth speaker for today is Stephen Barrett. So Stephen Barrett is the lead, carbon lead at the Irish Green Building Council. So over to you, Stephen.
Okay, I'll try and be quick because I'm very aware of the time. So reasons why we should be looking at our buildings from a whole life carbon point of view. The CSRD is probably the main thing right now. So for anyone who's not aware, the Corporate Sustainability Reporting Directive requires larger companies and all listed companies, except little micro companies, to report on a range of sustainability factors, including not only their own environmental impacts, but also those of their suppliers, their Scope 2 and Scope 3. So your Scope 2 is the carbon footprint of the energy that you use, essentially. But your Scope 3, that is the emissions caused by the value chain that you benefit from, that a company uses. So the emissions that your suppliers are responsible for. Now, in the building industry, that would be the emissions associated with the assets that you commission and that you pay for. So large corporate investment vehicles looking to fulfill CSRD requirements are now starting to ask for whole life carbon assessments of buildings so that they can fill out their Scope 3 reporting requirements for the CSRD. And I think that's something that's only just starting to become clear. We're certainly seeing a lot more inquiries, people saying, why are they asking for whole life carbon assessments? And this is the fundamental reason, CSRD. Now, how they're doing that is the EU taxonomy. So the EU taxonomy is a classification system that aims to define which economic activities are environmentally sustainable and which ones aren't. It's a tool for the financial sector to agree, identify, and invest in sustainable activities. So there's obviously a lot of activity going on to invest in. So it does this through technical screening criteria. Within building and within whole life carbon specifically, the technical screening criteria it looks to is levels the European Framework for Sustainable Building. Now, within levels, it's got various definitions of what a sustainable building is, but from a carbon perspective, it has this indicator 1.2, which is carbon emissions over the life cycle of the building. So levels defines how you measure the carbon emissions of a building over its lifetime. That's within the taxonomy. The taxonomy is the framework for financial decision making, if you like, and the CSRD is the requirement to report on these things. So they all kind of lock together. But these are the things that are driving investors to ask building designers, give me a whole life carbon assessment of your building design. This is where it's all coming from. So what it's doing, what these things are doing together, I guess, is they're creating this increased demand for knowledge in this area. I can hear my kettle boiling. Standardized methodology for doing this measurement and better data to underpin whole life carbon assessments. So the key indirect effect of all this will be increased investment in low carbon building products and production processes to produce better scores in those whole life carbon assessments. So what it's doing is it's kind of sending a signal up the supply chain that if you provide the information behind your products, and obviously the better the scores in that information, the better the reporting, the better the access to financial terms for investors. This is kind of a chain of information next to a chain of supply, if you like, in order to access better financing. So that's why we're starting to see whole life carbon assessments being asked for, particularly on bigger projects. There are a couple more things pushing this, but I think those two are the key things today. They're being asked for today. We've got the EPBD recast, which is going to start pushing this from a regulatory point of view, probably from 2027, but possibly earlier. Currently, the European Commission, Council and Parliament are in trilogue trying to agree exactly what the EPBD recast looks like, but they are all agreed that it will have some form of whole life carbon reporting in it. And just when will it be required and for buildings of which size is the kind of the only question. So as well as the finance, which is already pushing these decisions, we've got the actual regulation coming behind it. The CPR, the Construction Products Regulation, similarly is being recast, and it looks like that's going to require building products to declare their carbon footprint of their production when they're placed on the European market, which is really important for doing whole life carbon assessments. In a very simple terms, if you know the carbon cost of producing one concrete block, just multiply the number of concrete blocks you're using by that carbon cost of one block, you've got that part of your jigsaw, if you like. So when the CPR is forcing manufacturers to declare what's going on in their factories, then hopefully we'll start to see competition there too, as they try to compete to produce good materials at as low a carbon cost as possible. So for me, that can't happen fast enough. Ireland's response then, the Climate Action Plan. I'm just really conscious of time. So the key things here is a methodology for measuring this whole life carbon assessment. How do you know exactly what to measure? So we're working on that right now with the SEAI. We've produced a methodology and it's out for testing. We've sent it out to, must be 40 or 50 building design teams at this stage who are using it, trying to apply it to their live projects to calculate the footprint of their current projects. And in that way, we can figure out where we are today, what's our kind of baseline today. As well as the methodology, we've also provided a database of average carbon factors, generic carbon factors for different building materials to help them. And it helps them in two ways. Often you can't get that carbon information for a product because the manufacturer doesn't supply it alongside the product. There's no EPD, or there may be an EPD, but it's not in the right format for you, or you may just not be aware or familiar with EPDs. environmental product declarations. So we're providing, alongside the methodology, a database of construction products that gives you an approximate indication of what the carbon footprint of each element of your building is going to be. The aim being you can construct your whole life carbon assessment, use that database of products to inform it and send it back to us, and we get a kind of a consistent set of assessments back. So once we've created this methodology, the aim is to use it to discover what our baselines are, what is our typical building in Ireland today, what does it look like from a carbon perspective, and from there we can start to set targets on lower emissions in the future. Sorry, I'm just trying to speed this up a bit. The methodology, once we've done more testing on it, it's going to be sent back to the SEAI with the recommendation that this is the single method for doing carbon assessments in Ireland, driving that awareness that we're now measuring the carbon footprints of the materials that go into your building, sending a signal up the supply chain that lower carbon products will be preferred in the future. So just a quick bit on the methodology. Levels provides a materials scope. So what parts of your building do you need to be including in your assessment? Because obviously the more parts you use, the higher your score is going to be, but also the more transparent your score is going to be. So we need everybody conforming to that same level of scrutiny, if you like, so that we can start looking at projects and comparing them across organisations, across the EU, and again, against that taxonomy to access better funding terms. This is the scope. I just thought I'd show that quickly. The scope of what you should be including in an assessment of a building. So everything from the foundations to the landscaping railings and everything in between. Currently, it's a bit of a wild west. You'll see some really good scores saying, oh, 200 kilos of CO2 per square metre. But the first question you should ask is what's included in that scope. And you might find out that they've left out the fittings and furnishings, all the ventilation systems, the wiring and everything else. So this kind of says you have to have all of this in it for a consistent and fair measurement. Levels provides a template for doing this. It tries to reduce everything down to masses. So kilos of different parts of your building, if you like. You can assign a carbon factor to a kilo of a particular material. And again, it's just that kind of summing up then, how much of this are you using in your building? So we need product data. And if we don't get it, we can use generic averages that we've already got. I'm just trying to speed this up. What else? The completeness and the consistency. The last two things on that list are the things that get overlooked. Make sure that everything in that scope is used and that you're consistent in your assumptions about the lifetime of that building in the future. And I just want to show you this slide that kind of proves that, if you like. So we carried out an assessment on a building using one-click and this indicate methodology. And you can see in the different stages of a building's life cycle, which is the A to C across the top there, massive variation. We're able to explain the variation, but the point is we need consistent assessments. The variation came from different assumptions about the carbon footprints of materials, different assumptions about replacement rates, and different assumptions about what will happen at the end of life. We need those all to be standardized so that we're comparing our buildings fairly. We know what they are in the indicate methodology. We weren't too clear what they were using one-click. Indicate is consistent in speaking to levels and to the Irish context of the materials that we use. What else do I have to say on this? Yeah, so we've got 15 done so far. We're just checking them for completeness and quality, but we do want lots more so that we can check the methodology is reasonable and create a baseline that will tell us what building in Ireland today looks like using this methodology. And then we can start setting targets for buildings using the same methodology so that we're comparing where we want to be with where we are today. very quickly we're starting to see patterns. So this is just a bit of a result that we've got back from one of the assessments. This is really important: total mass per square meter of the building and total MEP per square meter. This can tell you what's plausible in a building. So you'll have a range, if you like, of what's plausible in a building. And the more assessments we do that we're happy with, the more we can trust that range, that we're getting plausible data in future assessments. So that's really key. The completeness, how much of that scope has actually data being provided on, is really important too. So we can see very quickly how much of that building has been included. And of course, the all-important embodied carbon per square meter. The pie chart just shows you there. You can see we have almost a third in the operational energy. The B6, the passive house, aims to reduce. But you've got 2/3 here in the actual construction of the building. So we've got regulations on operational energy, but nothing on what you build the building out of. So the other bad thing about this is most of this happens at year 0 when you build the thing. The operational energy happens slowly over the years as you use the thing. So it really highlights a massive carbon footprint that's not being addressed. And that's what we're aiming to do here with this methodology. So once we've completed it, we can refine our baselines. So this is where we are today, give the methodology back to the SEAI. The aim then is to try and integrate it into BIM for speed and accuracy. And because this has more of an effect in a building design if it happens at the beginning of the building design than towards the end when you've already made all your decisions. So the easier we can make it a kind of integrated, automated application running next to your building design, if you like, then the more you'll be able to use it to compare different designs to try and lower that embodied carbon. We've also obviously got a lot of training and awareness work to do. If you have any building designs and you're curious about their embodied carbon, get in touch with me, because we want to test this on as many projects as possible. So any building at all, I'll share the methodology with you, and you can contribute to the project. I think we may be out of time. How are we going?
Brilliant. Thanks a lot, Stephen. Okay, so we're just running out. Well, we have run out of time plenty. So what I just want to do to just I suppose close out is just to thank all our speakers. So Jeff, Olga, Hugh, and Stephen. A lot of knowledge here today from all the speakers. So really thank you for that, and answering all the questions as well afterwards. So thanks to our speakers. The recording will be made available up online in the next few days as well. So this is part of the Sustainability Planning and Construction webinar series by Construct Innovate. Our next webinar is on next Tuesday, the 10th of October, and that is all around the design and operation of facade systems for better indoor environment. Some great speakers there, 3 great speakers, all based out of the Netherlands, Peter, Magda, and Raoul in there. So a lot of experience there to share. The first 2 webinars are up online already, available up online. If you go onto the Engineers Ireland TV, you'll find those there. And this one from today, the Passive House, will go up online. And then the remaining 4 webinars of this series are there. So we move into transport, circular economy, heritage, culture, communities, and sustainability as we're going on.